Hey there, Dr. A here, founder of the Learning Liaisons, and in this video, I've got a challenge for you. I'm going to give you 5 practice questions that cover the topic of probability. Now, you might be thinking, well, Dr. A, what grade level does that have to do with? What exam? Is it FTC? Is it Texas? Is it Praxis? The good news is when we talk about most of these exams, especially math, content's content. It doesn't matter what certification test you're taking. If you have to do math, like for example, middle school math or high school math or elementary school math, these topics are applicable. So my challenge to you is I'm going to put 5 questions on the screen. Before you move any further, I want you to pause that video, grab a pencil, because we don't want to do math in pen, obviously, right? Pencil and a piece of paper. And when a question comes on the screen, I want you to hit that pause button and time yourself, right? Give yourself 60 seconds, 90 seconds to complete the problem, right? And when you're ready, hit that play button again. And then our math specialist, Amy, who's featured in our boot camps at the learningliaisons.com website, is going to work through that solution for you. And if you have any questions, drop them in the comments below. Let us know what you think about the problems. Let us know what test you're prepping for. We want to hear from you. So quick recap. I'm going to put 5 probability questions on the screen, one at a time. Hit pause after the first one. Give yourself about 90 seconds to complete it. Then hit play and Amy will go over it and we'll just rinse and repeat that process for 5 times. You ready? All right, before we get to those questions, make sure you like the video. Drop a comment below. Let us know what test you're prepping for. And do me a favor, hit that little icon of the bell. This way you're notified whenever we give more videos on content like this for you. All right, so without further ado, let's get going.
John asks his friend to pick a random number between 1 and 20 inclusive. What is the probability that John's friend selects a number that is a perfect square? The first thing that we have to understand is that inclusive means that we are including the number 1 and 20. So if we count the number of numbers between 1 and 20, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 numbers. So when we're looking at a probability, we want the number of desired outcomes on the top, and we want the total possible on the bottom. That said, we know we have 20 total possible outcomes because there are 20 numbers. Now, the desired outcomes are perfect squares. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and that's not between 1 and 20. So we have 4 desired outcomes. So our answer is 4 over 20. But you'll notice that that's not an answer choice. So we must simplify. We can divide, if I can divide them both by the same thing, then that's how we simplify. So I can divide them both by 4, and I get 1 out of 5. So the probability that John's friend selects a number that is a perfect square is 1 out of 5. A jar contains 10 white marbles, 5 red marbles, 6 blue marbles, and 7 green marbles. If a random marble is selected from the jar, what is the probability that it is a blue marble? When we're looking at probability, we're looking at the number of desired divided by the total possible. So that means that we need to figure out the total possible choices from this jar, and then we need to look at what we want. What is the desired? So we're going to add 10 marbles plus 5 plus 6 plus 7, and that's going to give us the total possible marbles in this jar. So 10 plus 5 plus 6 plus 7, 15 plus 6 plus 7, 15 plus 6 is 21, plus 7 is 28. So there's 28 total possible marbles in this jar. Now, what is the probability that it is a blue marble? So we need to look at how many blue marbles are in the jar. And that number is 6. So 6 out of 28 is the probability, but we don't see that answer choice here. So we have to divide the numerator and the denominator by the same number to see what the simplified version of this fraction is. So I can divide them both by 2. 6 divided by 2 is 3. 28 divided by 2 is 14. So 3 out of 14 is the probability that I'm going to pull a blue marble out of this jar. If 2 6-sided dice are rolled, what is the probability that the sum of the two numbers is 5? So again, when we're finding probability, we're looking at the number of desired outcomes divided by the total possible combinations. Well, if I have a 6-sided dice and then I have another 6-sided dice, by rolling them, they are independent of each other, which means rolling this dice isn't going to affect how this dice rolls. So there's 6 possible on this dice and there's 6 possible on this dice. So if I multiply those together, I get 36 total possible combinations with the 2 dice together. Now, I'm looking for a sum of 5. Well, what would a sum of 5 give me? A sum of 5 would be 1 plus 4, 4 plus 1, 2 plus 3, or 3 plus 2. I can't have a 5 and a 0 because there's no 0 on a dice. So the total possible outcomes, not the total possible, the number of desired outcomes would be 4. And 4 divided by 36, if I divide them both by 4, I get 1 out of 9. So the probability that I would have a sum of 5 is 9. A school has a rule that student uniforms can only consist of a polo that is either red, green, blue, yellow, or black, and pants that are either black, khaki, or gray. How many different uniform combinations can a student choose from given these options? Well, the quick and easy way to do this is if I'm trying to find outfit combinations or sandwich combinations or something like that, you just multiply. So I'm going to take 5 shirts times 3 pants, and that gives me 15. But I'm going to show you a visual of why that is. So if I have this set of pants and this set of pants and this set of pants, there's my 3 pairs of pants. Each pant can have 5 shirts. Options. I can wear any of these 5 shirt options with each of these pants. So that's 5 plus 5 plus 5, which is 15. In a standard 52 card deck, what is the probability that a randomly selected card is an even number? Well, if I'm looking at this, I'm looking at probability, which means I have desired over total number. I know my total number is going to be 52 because I have 52 cards. Now, what's the probability that it's an even number? If we're looking for an even number, the jacks, queens, kings, and aces don't count. So each deck has 4 different suits. They have the hearts, the diamonds, the spades, I don't even know if that looks like a spade, and the clubs. And each of those has numbers 1 through 10. The even numbers are going to be 2, 4, 6, 8, and 10. And that's going to be for each of these. So there are 1, 2, 3, 4, 5 even hearts, 5 even diamonds, 5 even spades, and 5 even clubs. And then these are not even, so I can't include those. So that's 5, 10, 15, 20 even numbers. Now I can go ahead and simplify that. I'm going to divide them both by 2. And that's going to give me 10 divided by 52 divided by 2. I could use my calculator, but I'm not going to for this. 26. Now I'm going to divide them both by 2 again. And that gives me 5 out of 13. One misconception or one common error that people are going to make is they're going to choose half because they are going to automatically think, well, half the deck is even and half the deck is odd. But remember, we cannot include the jacks, queens, kings, and aces.
All right. I am sure you did an amazing job, but don't worry. I don't care if you got all of those 5 questions wrong. It doesn't matter. What matters is you understand the why. Why did you get it wrong? At the core of everything, especially when we're talking about math, you've got to understand the concept because you will not see those questions on your certification test. You won't, but you will see, I guarantee you will see that skill. And once you understand the concept and that skill at its core, it doesn't matter what they throw at you. It doesn't matter if it's a big paragraph, word problem, or whatever. You're going to know that concept, have that level of confidence, and knock that problem out of the park and be done with it. Make that one of your low-hanging fruit, easy win questions. So hopefully those practice questions help you. If you want the full Monty, the full support, and get everything you need to pass your exam, make sure you check out our video boot camps on our website. The link is below in the description. We have a wide range of prep for Texas exams, Praxis, and the Florida Teacher Certification exams. So, hope you enjoyed that video. Please make sure you like, comment, and subscribe. It helps out the YouTube algorithms so more teachers like you can get the support that they need with practice problems like this on our YouTube channel. So have a great rest of your day. And remember, it's when you pass, not if you pass your certification exams. We've got your back.